Okay, let me show you a trick on how you can get the confusion matrix right every time. Trust me, you will never forget it after watching this video. So we all know that the confusion matrix looks something like this. I'm not perfect at the drawing, but go ahead with the idea. So let's say this is the confusion matrix. Let me change the colors up here. So we have drawn the confusion matrix. Now we need to fill in these values. Let's say we are doing this for a binary problem, a binary classification problem. So we have two labels. We have the positive label and the negative label. Let's say for simplicity, we name this one as positive. This one would be negative. Similarly, this one is positive and this one is negative. Now, what axis should be labeled as predicted and what axis should be labeled as the true or the actual labels? That totally depends on you. I don't have any problem with that. But since truth is always above everything, so we'll write that the true axis is this one, or the true labels are this one, and this indeed goes into the predicted labels or the predicted axis. Okay, now we need to fill in these values. So first, let's take a step back and see what these individual terms mean, like TP or true positive, false negative. How do we figure out that what they actually mean? So the simplest trick I'll just show you in this one. Let's say we have any metric in the confusion metric. Let's start with true positive ones. So what each of these individual characters denote is, so the second character denotes what was the prediction that we got. Okay, what was the prediction label that we got? It was positive or it was negative. So in this case we know that it's a positive prediction that we have received. The first letter shows that if it was true, right? So to sum it up, if we take this down, so true positive means that the predicted label was positive and it was correct as well, or in other words it was true as well, as we have seen up here. It is simple, right? Let's see for another example. Let's say we want to find out what does false negative means. So we can definitely decode this with the methodology that we have seen up here, that the prediction was negative. Okay, and was it right? No, it was false or incorrect prediction. Makes sense, right? So keeping all this in mind, let's try to fill the confusion matrix that we have up here. So the prediction was positive and it was actually positive. So we have positive positive, so it's going to be true positive. The prediction was positive, but actually it was negative. So it is going to go in false positive, since the prediction was positive, but it was indeed wrong. Similarly, we can fill the other fields as well. Give it a try. So the prediction was negative, so we put here n. And was it actually negative? No, it was actually positive. So we put the prediction is false. Similarly for this one, you can guess it. It's going to go as true negative. Believe me, this is, I think, the best way to remember what is these individual metrics mean, and you can draw confusion matrix based on this every time correctly. Okay, so this is sorted. Let's just clear everything up. Now let's just define the few metrics as we all know. Let's just define precision and the recall. So we're going to first define what these individual terms mean. What does precision and recall mean? And we'll try to construct the formula based on the definition from the confusion matrix that we just saw previously. Starting off with precision. So precision means that we'll just first see it in English terms. So precision says that of all the labels that were predicted as positive, how many of them are actually positive. Okay, let's just write down the definitions for the sake of it, then we'll understand what they actually mean and how to derive the formula out of it. Now we write recall. So recall is kind of an inverse of it, but not literally. So recall says that of all the values or all the labels that were actually positive, how many of them did we predict as positive? You may take a second and understand what all these mean. So again, let's just read them. So precision says that of all the labels that were predicted as positive, let's just highlight these words as well. So predicted as positive, in case of precision, how many of them are actually positive? And in case of recall, of all the labels that were actually positive, how many of them did we predict as positive? Right? Now it may seem that they are one of the same thing, but let's just look at the confusion matrix again. I'll just draw it up here quickly. So this is how our confusion matrix looks like. So we have TP, we have FP, we have false negative, and we have true negative. Here we have the actual ones, and here we have the predicted ones. Now according to the definition of precision, let's just write it as P, of all the labels that were predicted as positive. So this thing goes into the denominator. Now the things that were predicted as positive, right, were this and this. So we are focusing on the last character up here. So positive, positive. So here goes TP plus FP. Positive labels predicted correctly and positive labels predicted false or incorrectly, right? And now in the numerator we are looking at how many of them are actually positive. So we mean that the ones that are predicted correctly as positive ones. So in the numerator goes TP. This is the formula for precision that we have up here. TP divided by TP plus FP. Similarly for recall, right? Give it a try on your own. So for all the labels that were actually positive, right? Now we are focusing on the actual part of it. And if you remember, this was the positive thing and this was the negative thing. So the actual positive ones were this ones. So the actual positive ones were TP plus FN. Now this thing comes because they were predicted as negative and they are incorrect. That means they were positive in the first place or in the actual labels. So we have the denominator, and now we want to see how many of them did we predict as positive. So again, TP goes here. So this will be your formula for recall. Take a second, try to grasp this into perspective. If you want, you can stop this video up here and try everything from the scratch. I mean, the video is almost come to an end. And this is how you remember the confusion matrix and precision and recall. Now, what is F1 score? You may ask. Let's just define that as well. So I'll just maybe scroll down a little bit. Okay, so we have the precision and the recall values. F1 score is basically the harmonic mean of precision and recall. So the harmonic mean of any two variables x and y, it is stated as 2 times precision into recall divided by precision plus recall. And in almost all the cases, F1 score lies between precision and recall, since it's a harmonic mean, the basic mathematics that kicks in. You can try this on your own, calculate these 3 things by yourself, precision, recall and F1 score, and you'll see that F1 score is falling between recall and precision. Alright, so that is it for this video. If you enjoyed this, let me know in the comments. Surely I want to create more videos like this one, and I'll be happy to do so if someone is willing to watch it. Thank you for watching till end. My name is Rishabh, and I'll catch you guys in the next one. Bye bye.